Good morning, everyone. I hope you all are having a great time at Delhi. I certainly am. And yeah, I'm looking forward to the rest of the conference. Right, so this talk is titled The Hitchhiker's Guide to Testing Kubernetes. And in this talk, we'll look at how the Kubernetes project is tested, why we need to test it, and how you can get started with running all these tests in your machine. So a little about myself. My name is Sreeram Venkitesh. I've been part of the Kubernetes community for a little over 2 years now, which is crazy to think about. And I've been part of the release team for the past 4 cycles. And I also help write the last week in Kubernetes development newsletter as part of SIG comms. All right, so we are in the 10th year of Kubernetes now, and as of today, we have over 2 million lines of code. And it is important that we test the Kubernetes project since we are dealing with a project that is at this scale, which is responsible for managing infrastructure around like throughout the world. So we need to make sure that our code does what we expect it to do and nothing else. So this is something that you might have seen if you have like opened a pull request to the Kubernetes project. There are a lot of different tests that run as CA jobs against your pull request, and if you are not familiar with it, you can open a pull request and you might break a lot of these jobs. So there are two aspects of this. Whenever you're opening a pull request, you can like the changes that you make to the code can either break existing tests, which is what happened on the left-hand side. I opened a pull request without knowing that some tests are being broken. I did not run the tests locally. I just opened the pull request and like I started getting a lot of notifications from Prow that the tests are breaking. And the funny thing is that they send a notification every time a test is breaking. And I was getting a bunch of these notifications and I got nervous. So that was what happened on the left side. And on the right side, like apart from fixing existing tests, you also need to write tests for the new code that you're adding. So these are the two like scenarios where you would need to work with tests in the Kubernetes project. So it is at this point of time that you would start like looking into how Kubernetes is tested and all the different things that go behind it. And these are all the different like, tools and different concepts that I came across. And it can be overwhelming if you're doing it for the first time. It certainly was for me. And yeah, so this talk is something that I wished I had a couple of months back when I was working on a KEP. I was in this situation, I had to fix existing tests, and I was asked to write new tests, and I was like I had to figure out all of this, and I wish that there was a talk which gave everything to me. Yeah. So in the rest of the talk, we'll look at all the different kinds of tests, how you can run them locally, and how you can write your own tests. So the first one is unit tests. So if you have learned Go programming, this is similar to the kind of tests that you would write for your Go code. Unit tests are written with Go's standard testing library, and all these tests are contained within that individual package. So I have the Kubernetes source code open here on the side. I hope you can read this. So for each particular file, I have the pod util file open here, which has a bunch of helper functions with which you can work with pods. And for each of these functions, so for each of these files, we have a accompanying test file along with that, like in the same directory. And these are the unit tests. And for each function, so I have the visit containers function here. So what it does is if you give a pod spec and you can write a visitor function, which would go through all the containers in that pod spec and do something. So you can do things like check if any of the containers in your pod has a restart policy set or something like that. So each of these functions would have a corresponding test. So this is the test for the visit containers function. And this test suite has a bunch of different test cases. And what unit tests do is it calls whatever function that you're testing. In this case, it would be the visit containers function, and it tests the actual code itself. So unit tests are not aware of the fact that Kubernetes has a lot of different microservices which are running together, and it does not concern itself with that. All right, so yeah, unit tests are the most bottom layer of tests, and yeah, we have unit tests for each individual package, and oops, yeah, you can run these unit tests either using make, or you can run go test, and from this point onwards, there are links at the bottom of the slides where you can read the entire documentation about each particular topic, and yeah. You can run all the unit tests across the project using make test, or you can uh, like run the tests across a particular package. My slide formatting is not showing up there. Yeah. Uh, so I'm not going to go into the entire details of how all these tests can be run. You can find all that in the link given below. But I would like to talk about like my workflow. So I use VS Code as my IDE, and I have installed a Go extension. So because of that, I am able to run this unit test by clicking on this button here. So you can do similar things if you've configured your IDE to do that. So why I like this flow better is because I am able to write new unit tests and iteratively test them within the IDE without having to go back and forth between the terminal and my code. So usually what I do to write unit tests is I would copy paste one of these existing test cases, and then I start like playing around with the information that we are giving, like the pod spec in this case, and like iteratively run the tests until I get what I want. So I find that to be the fastest way to write unit tests with the most efficient feedback loop. So yeah, if you want to write new unit tests, the central source of truth for all the testing for every feature is the test plan section of the Kubernetes enhancement proposal. So if you read a KEP, you can understand the tests that are proposed by the authors, and you can compare it with the code PRs and make sure if all the tests are written. There can be cases where you find that that is not the case, so you can write new tests. You can also run the unit test coverage report, which would show you all the different files and like the test coverage for each line of code. That is also one way to figure out which files or which areas of the code are not well tested. So next we have integration tests. They're similar to unit tests in that they're written using Go's standard testing library, but integration tests expect components like etcd or the Kube API server to be running, against which it will test this code. So integration tests would be for things like testing if your code is talking to etcd properly and so on. So this is how you run integration tests. If you run make test integration, it would actually run this test integration.sh script, which if you see, you can see that we have like code here inside this file to start etcd before the tests are run. And once the tests complete, we clean up everything, and etcd would also be brought down. So for running integration tests, you need to have etcd installed in your machine so that the script can start etcd. And for testing the API server, you have this Kube API server testing package with which you can start a test API server against which you can test your code. I've linked the file from which I've taken the snippet at the bottom of the slide. So finally, we have end-to-end tests. So even if your feature has like really good unit tests and integration tests, since Kubernetes has a lot of moving parts, there can be like edge cases that can come up even if your feature is well tested. So we need to have end-to-end tests so that our feature is like tested against an actual running cluster, and that is what end-to-end tests do. The end-to-end test binaries run on an actual Kubernetes cluster, and it makes sure that the feature is working as intended in a real-world scenario. And unit tests are written using Ginkgo and Gomega like testing framework. They have their own domain-specific language with which we are able to write these tests. I will get into how we write these tests in a minute, but before that I want to share how I run these tests, because it can be confusing. Like, it took me some time to figure out what exactly we are doing with these tests. So I mentioned that E2E tests are run against an actual Kubernetes cluster. So for that, like if you're writing a new feature, if you're working on a new feature, you need to run these E2E tests against a cluster which has the code for your feature running. So if I work on a new feature and if I write an E2E test, it does not make sense to run the E2E test against older version of Kubernetes, like 131 or something, which does not have my the code for my feature. So what I do for this is I use kind to like build and test Kubernetes locally, and yeah, I have an entire workflow with kind, which I'll like get into in a later slide. But I use kind to build the node image of Kubernetes, which has the code for my feature, and I also run the second command here to build the E2E test binary, which would be run against this cluster. When I create the cluster, after that, I'll talk more about the cluster.yaml file later. And once the cluster is up and running, I use kubetest2. So kubetest2 is the canonical way to run E2E tests in Kubernetes right now. And if I run kubetest2 kind and mention like the deployer as kind and the tester as ginkgo, it would run E2E tests against my kind cluster, and this would pick up the local kubeconfig file that I have. So the tests would be run against my kind cluster. And I also pass a flag called use binaries from path. So this needs to be done for kubetest2 to pick up the E2E test binary that we just created. So I would like to show you how that works. So as part of my KEP, I made a change to this validate sleep action function, which validates whether a sleep action for a pod pre-stop hook can have a value of 0 or not. So based on a feature flag, I made it so that if the feature flag is enabled, you can have 0 as a valid value. So this was the actual code change that I had to make in Kubernetes, and I built a kind node image so that I can create a cluster which has this logic in its code. And I wrote an E2E test which tests this feature. So I'll get into the code in a bit. So you can see that I built the kind node image. So I have the binary for running Kubernetes with the new feature. And I also like built the E2E test binary, and I started the kind cluster with my new like binary. So this cluster.yaml file, I'll show that right now. This is used to configure kind so that it runs my latest binary. And since my feature depends on a feature gate, I also have enabled that feature gate here. And once the cluster is running, I ran the command that I had shared in the slide, kubetest2 kind, and the deployer is kind and the tester is ginkgo, and I have mentioned use binaries from path. So this ran the E2E test suite, the E2E test binary that we created in this step here against our kind cluster, and you can see that the test has passed. So you would also notice that I used another flag called focus regex, and I've passed my feature gate here. So I did this because I only want to run my test. So during the development workflow, I don't want to run run all of these tests. So if you run this command without this focus regex flag, like you can do that. It would like run all the E2E tests. So if you're someone like me who is from South India, who is like not familiar with the cold here, you can actually do that and cube cuddle with your laptop because your laptop will get warm. Not that I did that, I was just preparing for my talk yesterday. All right, so I passed this flag, and you can see that all the tests except for my test, the one dot that you see here, all the other tests are skipped, and you can see that the test has passed here. So while I'm developing this, while I'm writing the end-to-end test, I can quickly make changes to the test. I can run this step again to build the E2E test binary, and I can run the test again. So this I've found is the fastest way to run these tests while you're actually developing them. So you can you need not build Kubernetes again and again. You can just compile the test binary, and you can iteratively work on your tests. So I'll briefly talk about what this test actually does. So it is using Ginkgo's DSL. So I've described this test here with ginkgo.context, and we are testing whether a pod with a lifecycle hook using the sleep action of 0 duration actually works. And as part of this test, we first create a pod which has a sleep duration of 0, and this is why we had to enable the feature gate, because if the feature gate is not enabled, so if you're running this E2E test binary against a cluster which does not have the feature gate enabled, then it would break, because it would say that it would throw the error that sleep cannot be 0 seconds. And we create that pod, and we kill the pod, and we check the time with time.now and time.since, and we make sure that the time it took for the pod to get killed is between 0 and the termination grace period seconds, which is 30 in this case. So if that works, then we can be sure that the feature is working. And yeah, this is my workflow of writing E2E tests. So we also have E2E node tests. I was really confused about this until I was really confused about this for a long time, because the feature that I was working on was supposed to be I had to make the change in the kubelet code. So I was confused whether I should write my tests in the regular E2E tests or the E2E node tests. So the difference here is that regular E2E tests does everything through the Kubernetes API. So if you see the code here, we are actually when we create the pod, we are doing it through the Kubernetes API, and the E2E tests only talk to the API server. But E2E node tests are for testing features of kubelet which are not necessarily accessible through the API. So you can do things like SSH into the host which is running Kubernetes and do things there. And for E2E node tests, you need to only have etcd, kubelet, and the kube API server running. So if you are testing something with scheduling a pod, you would have to do that manually with this framework.pod client function, because scheduler is not running. So I had asked the question in the SIG testing Slack channel a couple of days back while I was preparing for this talk, and I got a bunch of good replies from people from SIG Node and SIG testing about the difference between regular end-to-end tests and end-to-end tests for Node. And yeah, they've described beautifully how you decide whether your feature needs to have an E2E test or an E2E node test. All right, so finally we have conformance tests. So as I've understood it, conformance tests are a subset of E2E tests which are approved by SIG architecture. And the conformance test suite is used by CNCF to provide the certified Kubernetes conformance program for different vendors. So if you are a vendor who is providing a flavor or a distro of Kubernetes, if you run conformance tests, and if your version of Kubernetes passes all the conformance tests, then you can say that your flavor of Kubernetes is identical to the upstream open source version that we have. And yeah, you can write E2E tests, and for features that are in stable state, your E2E tests can be graduated to conformance tests, and that will be used by all the different vendors to approve that. That will be used by CNCF to approve different vendors to say that the particular flavor of Kubernetes is identical to the open source version. Yep. I also want to share a few resources. So I was talking about how I use kind. So I wrote all of the details about that in the blog post. You can find that here. This should have things like how I enable feature gates, how you can have versions queue and test things like that. So that'll be interesting to you if you are someone who wants to work on Kubernetes and build new features. I also want to share a few talks that I had referred for preparing for this talk. The first one is a talk by Patrick Ollie at KCSNA last month. He is talking about a new framework called K-testing, which can be used to run, which can be used to write both E2E tests and integration tests in a similar way because they are more or less doing the same thing. Then there are also two talks by Priyanka and Jason here. They talk more about using kubetest2 in the context of CI and using Prow. I'm not that familiar with Prow, so you can like watch these talks if you're interested in that. Yep, that's all, folks. I hope you got to learn something new from this talk. I had like fun preparing it, and I. Thank you. I wish you all have a good rest of the conference. Yeah. Yeah. If you have any questions, I can answer them. Yeah.
So, do you guys attach this test result with the LDO report for the vendor resolution, or just the CLI reports, like one test passed? Do you have some kind of attachment with the LDO report, or some kind of other report? Unit tests, EQE tests.
I know that if you run the tests, like the test artifacts would be created here. So this would have all the logs of the tests that are run. I hope you can see the files there. Yeah, but I'm not aware of any other like report.
Okay, does
That
it
is.
get some kind of HTML LDO report or something like that, so that when you click it's kind of
I think if you want to see the reports of earlier tests, or like compare, we have test grid that shows like over span of time how that particular test is done. Flaky test, you can see like how the test is flaking for how long. So that would be testgrid.ktest.io. You can see a dashboard of all the tests that Kubernetes project has across E2E, Conformance, and everything. That
so
would
that
be
I'm saying
testgrid.ktest.io.
that must work after coding moves to the master and dropping.
Even on PRs,
Okay.
even on PRs that you are creating, it's not yet merged. You have something like pre-submit. That is, you. It's before submitted, before merged. You test your code against, assuming that your code is merged. You check out your code from that particular PR branch, and then you run set of tests. You can find those results on testgrid.ktest.io.
Yeah. Thanks, Priyanka.
If I can ask one more question.
Yeah.
So I have seen this already, like when we test with the kind cluster, any feature or any CNC product also, it has a very, what you can smooth result when you try with some other vendors also, like Azure, AWS, and Google, GCPs also. So do you guys, when do this testing, you show the kind version, perfectly fine. But do we also go for the other vendor testing so that we are sure it is working across all the different cloud flavor which is famous in the market? It's also working over there. There is no some kind of a edge cases with some specific vendor, or we don't care at all.
So I believe like I had shown the all the CI jobs that run in a PR
Yes.
earlier. So I believe there are tests which run across different cloud providers here, and about the point that you mentioned about how different features can break at like different cloud providers, that I guess becomes more relevant when a feature is graduating to stable. So before a feature gets graduated to stable, you need to make sure that the feature is like well tested across all the.
Yeah. Just trying to figure out, do we have a separate total steps to handle it, or we do in GitHub Actions, or manually there is a step we handle this type of scenarios like testing one by one, like this test cases in different clouds, or we have a proper streamline, like some kind of a E2E or something.
So most of the cloud provider related stuff is like abstracted out. So you use the cloud provider interface, and any cloud provider which has any dependent features can talk using that. So the conformance is usually the other way around. So Kubernetes builds a core set of features. It tries to not break anything and makes it generic enough. And then the cloud providers, when they bump a new version of their cloud provider and use a new version of Kubernetes, they are liable to test them and then push the conformance results to CNC of conformance. So that's how it works.
So coming back to kubetest 2, like we have a few resources. We have something called Boscos that runs in the Prau CI/CD. So Kubernetes uses something called Prau as a testing CI/CD. We do have some resources for Google Cloud, AWS, and I believe more cloud providers as well. That kubetest 2 would create clusters against those cloud provider, and then we'll run those end-to-end suites on those cloud provider, get the results, and then everything will be published on test grid. So we do have integration tests or end-to-end tests running against cloud provider. Same again, you can find out the list of those tests on test grid. There'll be like dashboards that the names would be helping you to understand what are the set of tests under those particular dashboard. But GKE, AWS, you can find out those names. Yeah.
Yep, thanks, Nambaru and Priyanka again. Thanks all.